Screwed. Okay, this video will be the solutions to pages 3 and 4 of the second review packet for the Algebra 2 final exam. This is a review for the open-ended and multiple choice sections of the exam. It should be a relatively comprehensive review of everything that we've done in first semester, going all the way back into our Algebra 1. So the graph on number 11 is the same problem we looked at on number 10 on the previous page. It is showing the height above ground of a baseball during a home run hit by some guy named Kyle. We're supposed to identify and interpret the y-intercept. So the y-intercept would be that point right there where it crosses the y-axis. It would appear that that point is 0, 5. So when it says identify, we would say the y-intercept is at the point 0, 5. And then interpret means we're supposed to write out in words what it means in the context of the problem. So in the context of the problem, that ball is being hit from an initial height of 5 feet. So we would say when the ball was hit, it was 5 feet off the ground. And that handles the identifying and the interpreting. The next problem shows a graph for the value of a share of stock during trading day. And we're supposed to use this to answer questions 12 and 13. So I've copied this onto 2 separate slides because we do need a little bit of room to explain. On number 12, it says on which intervals of x is the function increasing? On which interval or intervals of x is the function decreasing? So we just need to remember what increasing and decreasing mean. As we move from left to right, a function is considered to be increasing if it is going up. It is decreasing if it is going down. So if we look at this, from 0, x equals 0, to here at roughly x equals 2.5, in this section, it is decreasing. Then from 2.5, all the way over here to 5.5, even though it changes, it is still increasing. So for this section here, it would be increasing. And then from 5.5 through the end of the graph at 8, it is decreasing again. So we would say the function is increasing. When x is between 0 and 2.5. That's 0 to 2.5. Oh, I lied. That's not when it's increasing. Wow, smooth. Let's try that again. It's increasing in that middle section. That middle section is between 2.5 and 5.5. That is when the stock is increasing. It is decreasing from 0 to 2.5. And from 5.5 through the end of the graph, which occurs at 8. So again, we're showing this interval notation to indicate that we know that between time equals 2.5 hours and time equals 5.5 hours, the function is increasing. Between 0 and 2.5 hours, it is decreasing. And between 5.5 and 8 hours, it is increasing. Or decreasing, sorry. Wow. Okay. The other question about this same exact picture is asking to determine and interpret the end behavior of the graph. So all you're doing is looking at the very beginning and the very end of the graph. Okay? So as the trading day comes to an end over here at this point, is the function increasing or decreasing? At that point in time, the value of the function is decreasing. So if the function is decreasing at the end of the day, that would be That would be the third answer. However, as I look at this question is not great. Because if we look, the value at the end of the day is the same as the value at the beginning of the day. It's $30. So in theory, two of these answers are equally correct, which makes this a fairly bad question. Guess I should have noticed that before. The value of the stock is decreasing at the end of the day, and the value of the stock is the same as it was at the start of the day. Now, I guess in theory, though, given the way the question is worded, it does say interpret the end behavior. And B, this answer is correct, but it has nothing to do with the end behavior. So that must be what they're shooting for there. We're only looking at what happens at the end of the day. And at the end of the day, that particular chunk of the function is decreasing. It's getting smaller. So we would answer with C, would be the correct answer to that question. Okay, 14 and 15 ask you to determine if the relation is a function. We did one of these earlier. There cannot be any repeating x values. In order for it to be a function, there can be no repeating x values. So if we look at the domain and range on number 14, there are no domain values being repeated. So that is a function. It does not matter that there are two arrows pointed to the same value in the range. That is unimportant. What matters is that there's not more than one arrow beginning at the same x value, because that would indicate a repeated x value. Remember, these are x and these are y, and we can't have any repeated x values. So the next one here, you should be able to answer. Are there any repeated x's? Yep. So that is not a function, because x equals 5 repeats in the domain. All right, 16. A gas tank in a truck holds 14 gallons. The truck uses gas at a rate of 2/5 gallons per mile. The amount of gas left after X miles is found using the equation y equals negative 2/5 x plus 14. It says write the equation in function notation. All that you do to turn an equation into function notation is replace y with f of x. That is the only change. That's all that happens, is you just replace y with f of x. They mean the exact same thing. So, done. Then it says find some function values. Well, okay. Function value of 75, we just plug in 75 for x and evaluate. Function value for 130, we plug in 130 for x and evaluate. Function value for 350, we plug in x and we evaluate. That's all it is. We just plug in those values for x and then we simplify. So let's see here. Negative 2/5 times 75 plus 14. Feed it to the calculator. That's interesting. It's not a great problem, apparently. Negative 2/5 times 75 plus 14 is negative 16. So hopefully they got gas before then. Negative 2/5. You should say fifths. I'm not sure why I wrote thirds. Negative 2/5. You should say fifths. Times 130 plus 14. Would be negative 38 miles, or gallons. Yeah, gallons. So they would definitely have needed to have gotten gas by then. And negative 2/5 times 350 plus 14 would be negative 126. So that is all that they have to do. Now I will say that that means that this truck is getting pretty terrible gas mileage, apparently. But anyway, that is what we're supposed to do. I'm not real sure why those answers come out negative. That's not a very good problem. Okay, 17, 18, 19, and 20 are all asking you to solve linear equations. I should hope that you don't really need to listen to this part of the video because you know how to solve linear equations. But I will solve all fours if you don't. Remember that when we're solving a linear equation, the first thing that we do is distribute. Then we combine like terms on each side, then move the variables to one side, the numbers to the other, and divide. So here we've already got the first several steps done. We're ready to move the m's to one side and the numbers to the other. So we are going to add 4m and add 64 to each side of the equation. That will give us 66 equals 11m. And then we divide by 11. And we get m equals 6 for the answer to number 17. Number 18, this has fractions, so we have an important little piece of information here. Remember that we can clear fractions if we multiply everything by the denominator, which would be 4. So 4 times negative 9 and 4 times 3/4 k. Sort of ran out of room, but you get the idea. Multiply everything by 4. And when we do that, the fractions will cancel into the 4's. So our equation will become k minus 32 equals negative 36 minus 3k. That no longer has any fractions, which makes it easier to solve. So then we're going to move the numbers to one side and the k's to the other. So 4k equals negative 4 and divide by 4, which would give us k equals negative 1. 19 has a fraction and it's on the outside of a set of parentheses. So we should start by doing a little bit of work on it before we deal with the fraction. I would subtract 4 from each side and distribute this fraction. That would be what I would do in my first step. So when I do that, I would get negative 16 fifths a minus 12 fifths equals negative 28. So my common denominator would be 5, which means I need to multiply each of those terms by 5. Now 2 out of those 3 are going to cancel. That 5 will cancel and that 5 will cancel, which will turn this into negative 16a minus 12 equals negative 140. This is now a two-step equation, so we would add 12 to each side, which would give us negative 16a equals negative 128, and then we would divide by negative 16, and that would give us a equals 8. And then the final problem on the page is another one that's very similar. Again, I would subtract the 3 from each side and distribute the negative 1/2 to get negative 1/2 g minus 1/2 equals 3. Then you need to multiply everything by 2. So we're going to multiply every single thing in that entire equation by 2. So that would give us negative g minus 1 equals 6. Add 1 to each side. So negative g equals 7. And then all we need to do is divide by negative 1 to make it positive. So g should equal negative 7. That completes pages 3 and 4 of your